Good afternoon, guys. This afternoon I'm going to make a video for you on hyperbolas, which is our third type of conic. Okay, so let's start looking at a couple of equations for our warm-up that we do know. Letter A is just a nice circle, right? And a circle with a radius of 2. The coefficients of x squared and y squared are both 1, so we know that one's going to be a circle. Letter B is a nice ellipse, right? And so we've rewritten all of our ellipses in a form, in vertex form, so that we could graph them. And we could see how far out we go in the x and y direction, right? So we'd go out 4 in the x direction, out 2 in the y direction, and we have a nice ellipse elongated along the x-axis. So what happens now when we have a new equation, and that new equation actually has a subtraction sign, because while it looks like a circle and ellipse in various ways with the coefficients and the squares, it actually isn't an ellipse. So what is the shape of this graph going to look like? So let's go ahead and start with, just as we started with circles and the ellipses, and start with our intercepts. So what are the x-intercepts for this graph going to look like? Well, when y is 0, we'd end up with 2 and negative 2, right? If x is 0, it turns out that there is no y value, right? It's not defined. There's no real solution. So let's talk about some symmetry, because how else am I going to look at this? Well, it has x-axis symmetry, right? It has y-axis symmetry. It has origin symmetry. So x-axis, y-axis, and origin. So let's keep that as mind as we predict and get our sketch. Let's plug in x equals 3. And when you plug in x equals 3, we get 9, so 4 minus 9 is 5, and we end up with negative 5. We end up with y squared equals 5, or y equals root 5, so that's something up here. We could get positive or negative, actually, right? Well, we could also plug in 4, and if you plug in 4, we get 16, and 4 minus 16 is negative 12, the square root of that, so square root of 12 is a little bit larger, and so we end up with these nice, what I call diagonal, or sideways parabolas, right? Kind of looks like a parabola. Now, using our symmetry, this has x-axis symmetry, so that's good, but it also has y-axis symmetry, so we know that this graph is going to be produced over the y-axis, and so here is the sketch of a hyperbola. Ideally, those should look identical, right? For symmetry. Well, let's go to the next one. So now we have it reversed, and we have y squared minus x squared. So what does this graph look like if it's y squared minus x squared? So just think for a minute to yourself what would happen, right? Think about your intercepts. So what's going to happen? Let's see. Let's plug in our x-intercepts. So when y is 0, there actually are no x-intercepts. When x is 0, there are 2 intercepts for the y values, and we get 2 and negative 2. So following suit, this also has x-axis symmetry, y-axis symmetry, and origin symmetry. So let's go ahead and plug in when x is 1. If x is 1, we get 1, and then add 1, we get actually y squared equals root 5 again, or y equals 5, so y equals root 5, or negative root 5. So now we're going up and down, and so if we plugged in 2, we'd get 4, and we'd end up with y squared equals 8, so root 8. Well, again, this graph is going to look like this, right? And so the symmetry along the x-axis pops out here, but we said there's y-axis symmetry, and so this is going to be flipped about the y-axis. So these are both hyperbolas, right? One can open left or right, right? We can go left or right, or we can go up and down. And so how do we know the difference, whether it goes left and right or up and down? So if we look back over in the first one that we did here, we'll note that it started with x squared, right? And so x squared means we're opening right and left. We want when those values are going to the right and the left. If it's y squared, I actually think about back in Algebra 1 where y equals something opens up or down, and so our parabola opens up or down. So what do we need to do now? We need to know about more parts of the hyperbola, and we need to know actually how to graph a better sketch and what form to put this in. So that's what we're going to do next. Okay, so here we are with the general formula in vertex form without any shifting, right? Without any shifting for a hyperbola. So let's go ahead and actually put some numbers in here, because I think for some context that will help us. So let's go ahead and actually sketch x squared minus for y squared is equal to 16, okay? So we're going to put this in vertex form. So just as we did with an ellipse, we're going to divide by 16. So we have x squared over 16 minus y squared over 4, equals 1. Okay, so here's our sketch, or here's our equation that we want to sketch. So let's go ahead and just slide this over, and we're going to start it in the same fashion that we started an ellipse, okay? So what do I mean by that? Well, we're going to draw our grid, and on our grid, we're actually going to go in the x direction 4 units, 1, 2, 3, 4, and in the y direction, we're going to go 2 units. However, there's a difference here, okay? So instead of producing an ellipse, we're going to start with our vertices. Our vertices are along the x-axis, remember that, because it's x squared, so we're going to start with our vertices, and so this graph should open left and right. So the question is, how wide is that hyperbola going to go? Well, in order to determine the width, we're actually going to produce a rectangle. This rectangle is produced by the values for A and B, okay? And then we're also going to include these diagonal lines, which will be the asymptotes, for us to know how wide this graph will go, okay? So here are our, let me actually change that color so it sort of stands out a little bit. These are our asymptotes, okay? Our asymptotes are in red here. And then we're going to go ahead and let's just highlight the vertices. These are our vertices, and these open right and left. So how wide is this graph? It approaches both of those asymptotes. And so here's a better sketch of what that equation would look like, okay? So just like we had before, we have A's and B's, and then there's a C and there's a focal point. The focal point or foci land inside the hyperbola, just like they did in the ellipse. So this is going to be our value for C in here, C and C, okay, this the distance from the origin. And then let's go ahead in here and put in A and B. So A is along the x-axis, okay, it's always along the axis that contains the parabola, and B is along the opposite axis, or excuse me, that does not contain the hyperbola, not the parabola. So this distance right in here is A, this distance up here is B, and then C is the distance from the center to C in there. So how do we find C? Well, we find C in a similar fashion as we did before. We have A squared, B squared, and C squared. The only difference this time is that it's a plus sign. And so when I see you in class, I'll show you using the rope like we did before, how this equation comes out, because the value of C is actually the length of this diagonal in the triangle, right? So we'll measure it out and do that in class. So here's our equation. So I could ask you all sorts of things. I can ask you the vertices, right? And so the vertices on this equation are plus and minus 4, 0. I can ask you for the focal points or the foci, and so the foci would be 16 plus 4 is equal to C squared. So C is going to be equal to the square root of 20 or 2 root 5 plus or minus, right? So the foci, because they're from the origin, are plus or minus 2 root 5, 0, right? And then we have one more piece that we need to add. So I'm going to shrink this a little bit. So how about the asymptotes? We can actually write the equation of those asymptotes. Let's change that color. So the asymptotes right in here go right through our rectangle, right? Let's highlight that rectangle. Okay, and so the asymptotes, one positive, one negative, we're going to use point slope form. Y minus y1 equals m times x minus x1, okay? And so y minus y1 and x1 are actually the center of this whole figure. So in this case, it's y minus 0 equals, and then x minus 0, so that's nice. But what's the slope of this line going uphill? Well, we go up b and over a, right? Or if we look at our equation over here, it's the value of b over a or y over x. So it's 2 over 4, which reduces to 1/2. However, there's one that goes uphill, and then there's one that goes downhill, right? So we want to go downhill, which means we've got a plus or minus 1/2. If we trim this up, we can rewrite it as y equals plus or minus 1/2 x. Okay, so it's nicely in slope-intercept form. These are the 4 pieces I could ask you about. I'd ask you for a graph. The piece highlighted in red is the equation of the hyperbola, and we've got all these other bits. Okay, so let's do a fresh example. Our goal on this one is to find, sketch a graph and then find the center the vertices, the foci, and our equation of our asymptotes. Okay, so those are the few pieces we're going to look for. Well, we can find the center. The center is 0, 0. That's nice, right? Let's put this over 1 so we can see how far we're going in the x direction and the y direction. Let's go ahead and just change colors here for our graph. Okay, so our graph is going to go over here. Let's actually just shrink it a little bit. So our graph is going to go right here in the middle. Okay, so we're going to make our graph. Let's do it right over here. Actually, this will be nice. An xy axis. We're going to go over 1 in the x direction, and we're going to go up 2 in the y direction, and we're going to draw our rectangle. We make our rectangle dotted because it is not actually part of the hyperbola, right? And then from there, we're going to draw our asymptotes. Maybe you want to use different colors so that things stand out. Now, how is this graph going to open? Right and left or up and down? It's actually going to open right and left because we have x squared, right? So we'll start with those vertices, and then this is going to be a really wide graph. And so here is our hyperbola, really wide. Okay, so what are the vertices? Let's go ahead and land those over there on the right. The vertices are plus or minus 1, 0. Okay, and then the foci, the focal points, let's see. So we need to find C, right? C is in here. Okay, and so we have a squared plus b squared equals c squared. And so A is always along the axis that has the hyperbola. So we have 1 plus 4 is equal to c squared, so c is equal to the square root of 5. Now note, it actually doesn't matter which one's a or b in this case because it's a plus. That's what's so nice about this one. You can't get it wrong. You're going to get the right sum. It just helps if you know what a and b are, if that helps for you. So our foci are plus or minus root 5, 0. Okay. Now, lastly, our asymptotes. So our asymptotes are going to be in point-slope form. Let's start in point-slope form. So y minus the center, which is 0, equals, we need the slope, and then x minus 0. We got a little smudge in there, so let's erase that. Okay. So what is the slope of this line going to be? Well, we're going to go up on the x-axis, up on the y-axis, over on the x-axis. Up on the y-axis, over on the x-axis means 2 over 1, or just a 2. We want to go in both directions, plus or minus. Okay, so here's our second example, but what's different about this one is that it's y squared, so we want to keep in mind that this is actually going to open up and down, so maybe I'll just do a smile and a frown to remind us that we're going to go in that direction. Okay, so let's go ahead and draw a brief sketch. We're going to shrink this a little bit and put it over to the edge here, and then we'll make our list of all the pieces that we need. So we're looking for, the center's the same, so the center is 0, 0. We're not shifting right now. We want the vertices, and we want the foci, and then we want our equation of our asymptotes, y minus our center, which is 0, and then our slope, and y minus 0. X minus 0. Let's go ahead and erase that. And so we have x minus 0. Okay, great. So let's draw our sketch. Okay, so we're going to go out in the y direction 3 units, 1, 2, 3, 1, 2, 3, and in the x direction 2 units. We'll draw a rectangle. Please draw the rectangle. It makes for a more accurate graph. Okay, and then our asymptotes. Let's talk about our asymptotes here. So we're going up 3 over 2, right? Up 3 over 2, so we have 3 over 2, but we could go up 3 into the left 2, so we have plus or minus 2, gets us both, plus or minus 3/2 gets both of our asymptotes. Okay, so our vertices along the y-axis, this is a really much more narrow parabola than the last one. And we have 3 over here, there we go. And so our vertices are 0, plus or minus 3. And then we need the foci, or the focal points. So let's go ahead and find that. We have a squared plus b squared equals c squared. And so a is 9, and b is 4, and c squared, so c equals plus or minus the square root of 13. So we have, again, the foci are along the hyperbola, inside the hyperbola, so we have 0, plus or minus the square root of 13, and these are all of our answers. Great. Okay, and here's our last example. So what do you think we're going to do in the last one, just as we've done before? This one is in standard form or expanded form, and we want our equation in vertex form. So we're going to end on that, and when you get to class, we can check the vertices, foci, and asymptotes. So let's go ahead and complete the square here. I'm going to rewrite it, so x squared minus 2x, I like to leave a space for x, and then minus 4y squared plus 16y, leave a space, equals, I'll bring the 19 over, right, plus I'm running out of space. Here we go. Okay, let's shrink this a little bit more if we can, or slide it up. Let's slide it up. There we go. Okay, so half of 2 is 1, squared is 1, so we're going to add 1 to both sides, right? Oh, but over here we have a coefficient, so let's go ahead, we'll do a couple things at once. We've already completed this square, so we'll go x minus 1 squared, but then we have to factor out that negative 4, so we're going to factor it out. Be careful with the negative sign, because it's going to make our 16y actually a minus 4y. We're going to leave a space in there, and then we have 19 plus 1 plus a space. So half of 4 is 2, or negative 2, squared is 4, so we're going to put a 4 here, but actually what are we going to add to the other side is negative 16, right? Don't forget to distribute that negative 4. So let's go ahead, we're almost there. We have x minus 1, x minus 1, quantity squared, minus 4 times y minus 2, the quantity squared, equals 20 minus 16 is 4. And in final form, we are going to actually just go ahead and divide by 4. So we have x minus 1, the quantity squared, divided by 4, minus y minus 2, the quantity squared, divided by 1 equals 1. So here's our equation in vertex form. And for class, I would like you to find the vertices, the foci, and the asymptotes. Remember, the asymptotes, the best form is point-slope form. You can leave it in that form without transitioning it to slope-intercept form. Thank you guys. Have a good evening. See you tomorrow.